Zoom in to focus on this tetrahedron. Repetition of this building block gives a larger structure that retains this tetrahedral shape as shown here. Diamond is an example of a network covalent solid, which means that it has covalent bonds that extend in 3 dimensions throughout the structure. Instead of a collection of small molecules, a diamond is essentially one large molecule. As a result, diamond is a good conductor of heat and is one of the hardest substances known. The diamond structure can also be visualized as a cubic. Here we show the same 4 tetrahedra as in the last example, but inscribed inside the 4 opposite corners of a cube. This generates the same tetrahedron as shown before, only inscribed inside a cube. By tilting and rotating the cube, this tetrahedron can be displayed in the same orientation as it was seen before. Repetition of this cube also generates the diamond structure, but from the cubic perspective. Here we generate a larger scale model of the diamond structure by stacking this unit cell into an array that is 3 cells wide, 3 cells deep, and 3 cells high. Lonsdaleite is the hexagonal form of diamond. Like diamond, the carbon atoms in lonsdaleite are each connected to 4 others in a tetrahedral geometry. Also like diamond, 3 such tetrahedra are joined to form a puckered 6-membered ring. However, with lonsdaleite, this 6-membered ring is connected to a second 6-membered ring that lies on top of the first. This gives a structure that has a hexagonal rather than cubic geometry. Repetition of this basic building block generates a larger scale model of the lonsdaleite structure. Here we combine these hexagonal building blocks into a larger scale model. Note that the overall structure retains this hexagonal or 6-sided shape. Graphite is quite different from diamond and lonsdaleite. In the graphite structure, each carbon is connected to only 3 atoms. Since carbon must always form 4 bonds, one of the 3 bonds must be a double bond. This gives an average bond order of 1.33. Several different resonance structures can be drawn, depending upon the placement of the double bonds. In graphite, the carbon atoms are sp2 hybridized, with each carbon atom having a trigonal planar geometry. The atoms are connected to form a flat 6-membered ring that extends indefinitely in 2 dimensions. The structure of graphite consists of layers of these infinite sheets stacked one on top of another. The layers do not lie immediately on top of one another, but instead are offset as shown here. Let's take another look at the way these layers are stacked from the side. As you should be able to see, alternating layers are equivalent. The gray cylinders connecting like layers are for illustration only. There is no actual bonding between the layers. Graphite is therefore said to be a two-dimensional network covalent solid, as the chemical bonding only occurs in two dimensions. The fullerenes consists of carbon atoms arranged into spherical molecules. Like graphite, each carbon atom is connected to only 3 others. However, the fullerenes contain 5-membered as well as 6-membered rings. The most common fullerene is the C60, also known as a buckyball. This molecule contains 12 5-membered rings and 20 6-membered rings. These rings are arranged in a sphere resembling the soccer ball. Many other fullerenes are known. The next most common example is C70, which is a stretched C60 molecule. Other examples include C180 and C240, both of which are spherical. All of the higher fullerenes contain the same 12 5-membered rings but differing numbers of 6-membered rings. Let's take a moment to review. In the diamond structure, each carbon is connected to 4 others in a tetrahedral arrangement. The resulting structure can be viewed as tetrahedral or cubic depending upon your perspective. Diamond is a network covalent solid, which means that it has covalent bonds that extend throughout the structure in 3 dimensions. Lonsdaleite is the hexagonal form of diamond. As in diamond, each carbon atom is connected to 4 others in a tetrahedral arrangement. However, these tetrahedra are arranged to give a hexagonal or 6-sided structure. Like diamond, Lonsdaleite is a network covalent solid.